Welcome back. In this episode, we're diving into METARs, one of the most essential sources of weather information for pilots. METARs are short, concise reports that provide real-time weather conditions at airports, helping pilots plan safe and efficient flights. Let's start with the basics. What is a METAR? A METAR is a standardized aviation weather report that gives a snapshot of current weather conditions, including temperature, wind, visibility, cloud cover, and pressure. It's updated at least once an hour and can be issued more frequently when needed. The format of a METAR is quite structured. The report begins with the station identifier, followed by the date and time the report was issued, in UTC, Coordinated Universal Time. This allows pilots around the world to synchronize weather information, no matter their location. For example, a METAR for London Heathrow might look like this. Let's break it down. EGLL is the station identifier for Heathrow. 131720Z is the date and time of the report, 13th day, 1720Z. 28015G30KT tells us the wind is coming from 280 degrees at 15 knots, with gusts up to 30 knots. 10 SM means visibility is 10 statute miles. SCT030BKN080 tells us the cloud cover, scattered clouds at 3,000 feet, broken clouds at 8,000 feet. 13M01 shows the temperature, 13 degrees Celsius, and dew point, -1 degree Celsius. Q1010 is the altimeter setting, in hectopascals, HPA. Now, let's focus on winds in METARs. Wind is described by its direction, from which it's blowing, and speed. Winds are given in degrees true, meaning they are not adjusted for magnetic variation. The speed is in knots, and gusts are noted with a G followed by the highest wind speed recorded. The wind information in a METAR is critical for pilots to understand crosswind, headwind, or tailwind conditions during takeoff and landing. It also helps anticipate turbulence, especially near mountain ranges or frontal systems. Next, let's look at visibility. METARs use statute miles in the US and meters in other countries. Visibility is a key factor in approach planning, especially when flying into airports with low ceilings or poor visibility conditions. For example, mist, fog, or heavy precipitation can drastically reduce visibility and affect flight operations. Let's talk about cloud cover. METARs use specific terms to describe cloud conditions. You'll see terms like few clouds. SCT, scattered clouds. BKN, broken clouds. OVC, overcast. Each term is followed by the cloud base altitude, which is reported in feet above ground level. For instance, BKN 080 means broken clouds at 8,000 feet, while SCT 030 means scattered clouds at 3,000 feet. Pilots need to be aware of cloud conditions to assess visibility and flight restrictions, especially during approaches and landings. Another critical part of METARs is temperature and dew point. The temperature is important for calculating density altitude, which affects aircraft performance. The dew point is a measure of humidity. If the temperature and dew point are close together, it can indicate cloud formation or fog. For example, 13M01 means the temperature is 13 degrees Celsius, and the dew point is -1 degree Celsius. Next, we have the altimeter setting, or QNH. This is the atmospheric pressure at sea level, and it's essential for accurate altimeter readings. Pilots need to adjust their altimeter according to the QNH in the METAR to ensure they are flying at the correct altitude. For example, Q1010 means the sea level pressure is 1010 HPA. If the QNH is higher than normal, it means the aircraft is flying lower than it appears. Conversely, if the QNH is lower than normal, The aircraft is flying higher than indicated. Let's move on to special reports. Sometimes, you'll see SPECI in a METAR, which means a special weather report. These are issued when conditions change rapidly and require an update to the regular METAR. For example, if visibility drops quickly, or a severe thunderstorm develops, a SPECI report will be issued to give pilots up-to-date information. METAR reports are used not only for immediate weather conditions but also for flight planning. Pilots use them to determine when to land, whether to delay takeoff, and how to adjust routes in the event of changing weather. With real-time information, pilots can make decisions to ensure safe flights, avoiding turbulence, storms, or fog. Pilots also use METARs for approach planning. If you're flying into an airport and the METAR reports low ceilings and reduced visibility, you may need to prepare for an Instrument Flight Rules (IFR) approach. It's crucial to check the latest METAR before beginning an approach to avoid surprises. Another important note is how airport layout can influence METAR usage. For instance, airports in mountainous regions may have rapidly changing weather, and METARs provide vital information for flight crews to anticipate potential weather shifts like wind shear or rapid temperature changes. Let's now consider a real-life example, flying from New York to Boston. The METAR at your departure airport shows clear skies and a light breeze. However, the METAR at Boston indicates clouds at 2,000 feet, moderate winds, and light rain. By reviewing the METARs, you adjust your flight plan, deciding on alternate routes or weather updates en route. In the next episode, we'll dive deeper into METARs with Part 2, exploring specific reports and how they influence flight decisions. We'll also look at TAF, the Terminal Aerodrome Forecast, and how these reports complement METARs for approach planning and landing decisions. See you in Meteorology number 51, METARs, Part 2.